All right, so you're curious about artificial intelligence.
But feeling a little lost in the sea of tech jargon.
We've all been there.
Yeah.
Today we're going on a deep dive to demystify AI,
Stripping away the complexity.
to reveal the core concepts.
In a way that anyone can understand.
Think of this as your AI for Beginners guide.
Exactly.
We'll unpack the buzzwords
Explore the different types of AI.
and uncover how it's already influencing your life.
Probably more than you realize.
I think a lot of people hear AI and their minds immediately jump to,
Sci-fi robots.
but it's much broader than that, right?
Absolutely. AI is fundamentally about enabling computers to perform tasks that typically require human intelligence.
Things like problem solving,
Your name.
decision making,
And even creativity.
so things like my smart speaker understanding my requests.
Or Netflix suggesting shows I might enjoy.
Those are everyday examples of AI at work.
Precisely. AI is the invisible force behind many technologies we use daily. Facial recognition, unlocking your phone, or those chatbots you encounter online, they're all powered by AI algorithms.
Okay, so it's not just futuristic fantasy.
AI is already woven into the fabric of our lives.
But I've heard terms like ANI
AGI.
and ASI thrown around. What's the difference?
And should we be worried about any of them taking over the world?
Yeah.
Those terms categorize different levels of AI sophistication.
Okay.
ANI, or artificial narrow intelligence, is what dominates the current AI landscape. These systems excel at specific tasks,
Think of a chess program or a spam filter.
but they operate within limited boundaries.
So ANI is like a specialist,
Incredibly skilled in its domain.
but lacking the general intelligence of a human. What about AGI then?
AGI, or artificial general intelligence, represents a hypothetical level where AI possesses human-level intelligence across a wide range of tasks.
So imagine a machine that could learn and understand anything a human can.
AGI is still largely theoretical and a subject of much debate and research.
And ASI.
Artificial superintelligence.
That sounds like something straight out of a sci-fi thriller.
ASI refers to a hypothetical AI that surpasses human intelligence in every aspect.
Oh, wow.
It's a concept often explored in science fiction, but its realization
If even possible.
remains far on the horizon.
Okay, so for now we're primarily dealing with ANI, these specialized AI systems, but I keep hearing about machine learning as well. How does that fit into the AI puzzle?
Machine learning, or ML, is a core pillar of AI.
Okay.
It's the engine that drives the development of many intelligent systems. Instead of explicitly programming every step,
Like traditional coding?
we provide computers with algorithms that enable them to learn from data,
So it's like teaching a computer by example.
rather than giving it rigid instructions.
Yeah.
Precisely. Imagine teaching a computer to recognize cats by showing it thousands of cat pictures.
Okay.
The algorithm analyzes those images
Detecting pattern.
and eventually learns to identify cats in new images it's never seen before.
That's fascinating. It's like the computer's developing its own understanding based on the data it's exposed to.
Exactly.
But what about deep learning?
I often hear that term used alongside machine learning.
Is it just a fancy synonym?
Not quite. Think of deep learning as a specialized subset of machine learning that utilizes complex neural networks,
Okay.
inspired by the human brain.
Like simulating how our brains work.
These networks have multiple layers that process information in a sophisticated way, enabling them to tackle intricate problems.
So deep learning is like machine learning, with a turbocharged engine capable of handling much more complex tasks.
That's a good way to put it. Deep learning is the driving force behind realistic chatbots, instant translation tools, and even systems that can diagnose diseases from X-rays.
Wow.
However, it has a voracious appetite for data. The more data it consumes, the better its performance.
It makes sense that more data would lead to a deeper understanding.
Yes.
It's like the difference between trying to learn a language from a phrase book versus immersing yourself in a foreign country.
Right.
But I'm curious about another term that's been generating a lot of buzz.
Generative AI.
What makes it so special?
Generative AI represents a fascinating frontier in AI where systems can create new content.
New content meaning?
Imagine generating text, images, music, or even code. It's like having a digital artist at your disposal.
Wow, that sounds incredibly powerful.
So you could give it a description like a fluffy dog chasing squirrels in a park, and it would actually paint a picture for you.
That's amazing.
Exactly. Or you could ask it to write a poem in the style of Shakespeare, and it would produce something surprisingly convincing. Generative AI opens up a world of creative possibilities.
It's mind-blowing to think about its potential.
From generating photorealistic images to composing personalized music, This is starting to feel like something out of a sci-fi movie.
Yeah, it really does.
It's true, generative AI has the potential to revolutionize many industries.
But it's crucial to understand how it works.
At its core, generative AI relies on two key components: encoders and decoders.
Okay, let's break that down. What are encoders and decoders?
And how do they contribute to the creative process? Think of encoders as information compressors. They analyze vast amounts of data, like text or images, and condense it into a compact representation, capturing the essential patterns and relationships
So it's kind of like creating a blueprint.
of the data's core meaning. Yeah.
So the encoder boils down the information to its essence.
Right.
What does the decoder do with that blueprint?
That's where the magic happens.
Okay.
The decoder takes that compressed representation and uses it to generate new content.
It's like taking the blueprint and constructing based on what it's learned from the original data.
Yeah,
So it's not just copying, it's creating something original based on the patterns it's picked up.
exactly. And one of the biggest breakthroughs in generative AI was the introduction of the transformer architecture,
Transformer.
like the robots in disguise.
Yeah.
Not quite.
Okay.
Though the name is catchy. Transformers in AI are a type of neural network architecture that uses a clever mechanism called attention.
Attention.
It's like giving the AI the ability to focus on the most relevant parts of the input when generating new content.
Okay.
This significantly enhanced the performance of generative AI, particularly for language-based tasks.
So transformers help generative AI become much smarter and more creative.
Precisely.
Mm-hmm.
And within the realm of transformers, we have different types: encoder-only models,
Okay.
decoder-only models, and encoder-decoder models.
Gotcha.
Each has its specialties and is used for specific tasks.
Okay, so we've got these different types of transformers, each with its own strengths.
All right.
Tell me more about these specialized tasks.
What kind of things can these different transformer models actually do? Well, encoder-only models, like BERT, excel at understanding and representing text.
Okay.
They're used in search engines to better grasp your search intent
Oh.
and power those online chatbots, making them feel more natural and conversational.
So when I'm chatting with a bot and it actually seems to understand me, it's probably thanks to an encoder-only transformer model.
Most likely. Now, decoder-only models like GPT are the stars of text generation.
Okay.
They're the ones writing poems, drafting emails in various styles, and answering your questions in a surprisingly human-like way.
GPT?
That rings a bell.
Is that the technology behind ChatGPT?
You got it.
Wow.
ChatGPT is a prime example of a decoder-only transformer model in action.
It's amazing how realistic some of those AI-generated texts can be.
It's getting tougher to distinguish between human-written and AI-created content.
It's true. The lines are blurring.
And then we have encoder-decoder models,
Okay.
like T5, which are like the all-rounders.
Okay.
They're adept at tasks like translation, question answering, and summarizing large chunks of text.
So they're the multi-talented members of the transformer family.
You could say that. They can both understand and generate text, making them incredibly versatile.
Okay, all these pieces are starting to fit together.
Yeah.
We've got different levels of AI, different types of machine learning, and these impressive transformer models powering a wave of creative AI applications. It's an exciting time to be exploring this field.
It absolutely is. But as with any powerful technology,
Right.
it's essential to use it thoughtfully and be aware of its limitations.
Like what?
For instance, one area where AI still struggles is common sense reasoning.
Common sense reasoning. What do you mean by that? Isn't AI supposed to be...
Super intelligent.
Yeah.
While AI can excel at specific tasks and even outperform humans in certain areas, it often lacks the general knowledge and understanding of the world that we humans take for granted.
So even though AI can process information at incredible speeds, it can still stumble over seemingly simple things.
That we humans find intuitive.
Right.
Exactly. For example, an AI might be able to write a grammatically perfect essay, but struggle to understand the nuances of sarcasm or humor in a text. That makes sense.
Yeah.
It's like the difference between memorizing facts and truly understanding their context and implications.
Right.
So how are researchers trying to bridge this gap and equip AI with more common sense?
It's an active area of research,
Okay.
and there are several approaches being explored.
Right.
One approach is to train AI models on massive data sets of text and code that encapsulate human knowledge and reasoning. Another approach is to develop new algorithms that are specifically designed to mimic human common sense reasoning processes.
It sounds like a challenging task.
It is.
But if AI can overcome this hurdle, It could open up even more possibilities for its application in our lives.
Absolutely. Imagine AI assistants that can truly understand our needs and preferences, or robots that can navigate complex environments and interact with humans in a more natural and intuitive way.
Hmm.
These advancements could significantly impact fields like healthcare, education, and transportation.
It's fascinating to think about the future of AI and how it might continue to evolve and shape our world.
But let's shift gears a bit and dive deeper into the core building blocks of machine learning.
Okay.
What are some of the key concepts and terms we need to understand to grasp how these systems actually work?
Let's break down the core components of machine learning,
Okay.
the ingredients that make these AI systems tick.
Okay.
First up, we have algorithms.
Okay, algorithms.
That word sounds pretty techy.
What exactly are they in the context of AI?
Think of an algorithm as a set of instructions,
Okay.
a recipe that a computer follows to perform a task or solve a problem.
Okay.
In machine learning, algorithms are the brains of the operation.
Hmm.
They analyze data, identify patterns, and use those patterns to make predictions or decisions.
So it's like giving the AI a step-by-step guide on how to learn and make sense of the information it's given.
Exactly. And just like there are many different types of recipes,
Right.
there are many different types of machine learning algorithms,
Okay.
each designed for specific tasks. We'll get into those a bit later.
Got it. So algorithms are the instructions, the
Right.
recipe. What about the ingredients? What does AI actually learn from?
That's where data comes in.
Okay.
Data is the fuel for AI.
Right.
It's the raw information that algorithms analyze and learn from.
Hmm.
This could be anything: text, images, numbers, audio recordings, sensor data, you name it.
So all those cat pictures we talked about earlier, that's the data the algorithm used to learn how to recognize cats.
Exactly. The quality and quantity of data are crucial for training effective AI models.
Okay.
The more data you have and the more relevant it is to the task at hand, the better the AI will perform.
Makes sense. Garbage in, garbage out, as they say.
Right.
But AI isn't just about crunching data, it's about learning from it.
Right.
How does that actually happen?
That's where the concept of a model comes in.
Okay.
Think of a model as the brain that the AI develops after being trained on data.
Okay.
It's the end result of the learning process.
So the algorithm is like the teacher, the data is like the textbook, and the model is the student's understanding after studying the material.
That's a great way to put it. The model encapsulates what the AI has learned from the data and allows it to make predictions or decisions about new, unseen information.
Okay, so we've got algorithms, data, and models.
Right.
Those are some of the key players in machine learning.
Yes.
But I've also heard terms like features and labels thrown around.
What are those all about? Those are important concepts when it comes to preparing data for AI training.
Okay.
Features are the specific characteristics of the data that the algorithm uses to learn.
So if we go back to our cat example, features would be things like the shade of the ears, the color of the fur, the size of the eyes, those kinds of things.
Exactly. The algorithm analyzes those features to find patterns that distinguish cats from other animals.
And what about labels? Where do those fit in?
Labels tell the AI what the data represents.
Okay.
In our cat example, the label would simply be cat.
Okay.
This is particularly important for a type of machine learning called supervised learning,
Hmm.
where the algorithm is given labeled examples to learn from.
So labels are like the answer key, helping the AI understand what it's looking at.
Precisely. Labels provide the ground truth for the algorithm to learn from.
Yeah.
Without labels, the AI wouldn't know what it was trying to identify or predict.
Okay, so we've got algorithms analyzing features guided by labels to create models that can then make sense of new data. It's all starting to come together.
Yeah.
But I know there are different ways AI can learn.
Yeah.
What are some of the main types of machine learning out there?
You're right.
Yeah.
There are different approaches to machine learning,
Mhm.
each suited for different types of problems.
Okay.
One of the most common is supervised learning.
Okay, so supervised learning is all about giving the AI labeled examples, like those cat pictures tagged with cat.
Right.
What other types are there?
Another important type is unsupervised learning,
Okay.
where the AI is given unlabeled data
Uh-huh.
and has to figure things out on its own.
So no answer key this time.
Yeah.
How does the AI know what to do with that?
Instead of predicting a specific outcome, unsupervised learning algorithms search for patterns and relationships in the data.
Oh, okay.
They might group similar data points together,
Like categories.
a process called clustering,
Yeah.
or find associations between different variables.
So it's like giving the AI a giant jigsaw puzzle without the picture on the box.
That's a great analogy. Unsupervised learning is about finding the hidden structure in data without specific guidance.
That sounds pretty challenging.
It can be.
What are some real-world examples of unsupervised learning?
Think about customer segmentation,
Okay.
where an online store might use unsupervised learning to group customers with similar buying habits.
Well,
This helps them tailor their marketing efforts more effectively.
so they're not telling the AI what groups to create. It's discovering those groups on its own.
Based on the data.
Yeah,
Yes.
exactly. It's about finding hidden patterns and relationships that might not be immediately obvious to us.
Right.
Okay, so we've got supervised learning where the AI learns from labeled examples and unsupervised learning where it discovers patterns in unlabeled data. Yeah. Are there any other major types of machine learning?
There are a couple more worth mentioning.
Okay.
One is semi-supervised learning,
Okay.
which sits somewhere between supervised and unsupervised learning.
So, bit of both. How does that work?
In semi-supervised learning, the AI gets a small amount of labeled data
Okay,
and a much larger amount of unlabeled data.
got it.
It uses the labeled data as a starting point
Hmm.
and then tries to apply those learnings to the unlabeled data.
It's like giving the AI a few puzzle pieces with the picture on them and then letting figure out the rest of the puzzle.
Precisely. This approach is useful when labeling data is expensive or time-consuming.
Makes sense. What about the other type you mentioned?
The final type is reinforcement learning,
Right.
which is quite different from the others.
Okay.
It's inspired by how animals learn
Oh,
through trial and error.
so like teaching a dog a new trick with rewards and corrections.
Precisely. In reinforcement learning,
Okay.
an AI agent interacts with an environment and receives feedback
Like positive or negative feedback.
in the form of rewards or penalties for its actions.
Okay.
Over time, it learns to make decisions that maximize its rewards.
So this is like learning to play a video game.
You get points for doing well.
And lose points for making mistakes.
You got it. Reinforcement learning is being used to develop everything from self-driving cars to robots that can perform complex tasks.
Wow, it sounds like each type of machine learning has its own unique strengths and applications. It's amazing to think about the possibilities.
It really is. We've only scratched the surface of AI and machine learning.
Right?
There's so much more to explore, but hopefully this gives you a solid foundation to build on.
This has been an incredible journey. We've decoded the jargon, explored the different types of AI, and even peeked into the fascinating world of generative AI and transformers. I feel much more equipped to navigate the AI landscape now.
That's fantastic to hear. Remember, AI is a rapidly evolving field. Stay curious, keep learning, and don't hesitate to ask questions. The more we understand about AI, the better prepared we'll be to harness its potential and shape a future where AI benefits all of humanity.
And on that note, we leave you with this thought.
Yeah.
If AI can already create realistic images, write compelling stories, and even compose original music, what will it be capable of in the years to come? The possibilities are truly mind-boggling. Until next time, keep exploring, keep questioning, and never stop learning.